Good morning, everyone. My name is Daniel Prastio. Today, I'm excited to introduce SatLab latest innovation, the HydroBoat 1500 and USB specially designed for multi-beam bathymetry survey. Following the release of the HydroBoat 990 and USV with built-in single-beam echo sounder for bathymetric surveying and the HydroBoat 1200 multifunctional USV that can accommodate various sensors like a single-beam, IDCP, and side sonar, we are now pleased to unveil the HydroBoat 1500 designed for multi-beam echo sounder operations. Today, I'll take you through this innovative multi-beam USV. Whether the HydroBoat 990 or the HydroBoat 1200 USV, they are both designed to carry single beam echo sounder for water depth measurement. This has significantly improved the efficiency of the underwater topographic surveying compared to the traditional method. But there is a demand for higher precision, higher resolution, and more efficient survey tools when working in deep water and large areas. Compared to the single beam, multi-beam can measure more accurate underwater coordinate information with the help of high-precision sensors such as source velocity meters, altitude sensors, and tide gauge. As is well known, a single beam sounder employs a point-to-line measurement approach, while multi-beam echo sounder utilize a line-to-plane measurement approach. A large sweep width can bring higher working efficiency, and the hundreds of a thousand point cloud data on multi-beam can bring higher resolution. But why is multi-beam not as popular as a single beam? Besides the price, I believe there are other drawbacks. In the past, multi-beam systems were technically mounted on man-powered boat using bracket and poles for fixation. The operator will then follow the plane line while collecting data. However, this approach presents several challenges, including the difficulty of renting suitable boats in some areas such as forests, wetland, shallow water, dams, or reservoir. Even when the boats were available, they might require modification or custom mounted bracket depending on their design. Additionally, the multi-beam transducer needs to be positioned away from the noise source like engine and secure with wire ropes to minimize the movement. After a complex installation process, the system still requires the calibration on a specific terrain features like the survey area. Moreover, during data acquisition, the boat operator had to continuously adjust the vessel position to align the plane survey line. Manual vessel navigation can introduce error into the data collection process, and the deviation of the plane survey lines can lead to inaccurate bathymetric data, of course. This factor highlights the increased complexity and personal requirements of multi-beam operation compared to the single beam systems. Can we overcome these challenges and reap the benefits of multi-beam technology, including its superior efficiency, precision, and resolution? Thankfully, unmanned surface vehicles offer a compelling solution to these challenges. USVs are inherently portable, allowing you to transfer them to any desired location, whether it is a reservoir, river, or narrow waterways where large vessels struggle to maneuver. Their compact size offers a clear advantage in these scenarios. Moreover, the multi-beam sonar on a USV is permanently installed, eliminating the need of recalibration after its deployment. Simply launch the USV and it's ready to start collecting the data. Unmanned operation eliminates the need for personnel to enter the water, ensuring their safety. And it's easy to control and operate the USV, not requiring a professional handsman, which not only improve work efficiency but also reduce personnel costs. Not to mention that the unmanned boat is a one-time purchase, eliminating the need for rental fees. In a word, the combination of USV and multi-beam microsonder is a concrete example of synergy effects. Well, USB equipped multi-beam sonars are great solution. Why is the HydroBeam 15, HydroBoat 1500 the optimal choice compared to the option on the market? The answer lies in the following aspects. First of all, is a strong well-built platform, of course. It's for better stability in various conditions. A more powerful propulsion system, the efficient data collection across the largest areas. Next is a similar control system that is easy to learn and operate, so it will reduce training time and workload, of course. The last one is a more reliable sensor system for accurate and consistent data acquisition. In essence, the HydroBoat 1500 offers a superior combination of power, reliability, and user-friendliness, making it the optional solution for your unmanned bathymetric surveys. Let's start with this brilliant hull design. Inheriting the CFD optimized hull design of its predecessor, the HydroBoat 990 and the HydroBoat 1200, we have taken the HydroBoat 1500 design to the next level. It enhanced hull structure, enable closer adherence to the water surface across varying speed and wave condition, minimizing pitching and maximizing stability for precise data acquisition. A remarkable feature of the HydroBoat 1500 is its detectable two-man structure, comprising a central M-shaped hull and four side thrusters. The M-shaped central hull delivers exceptional seaworthiness. Its unique design minimizes vertical acceleration during high-peak maneuvering in choppy waves, reducing vibration by up to 50%. This not only enhance data measurement accuracy, but also protect the hull itself, extending its lifespan. The side thruster is equipped with additional identical thruster, not only boost propulsion, but also further enhance vessel stability. This configuration empowers the unmanned boat to handle nearshore and rough sea conditions with ease. In addition, the detectable side thruster provides versatility in hull configuration, facilitating transport and enabling single hull operation for surveying tight corners and narrow areas. The three-man design of the HydroBoat 1500 offers exceptional stability and provides superior buoyancy. This translates to sport payload of up to 60 kilograms while maintaining a shallow draft of 0.1 meters. This unique combination allows the HydroBoat 1500 to navigate through shallower water, expanding its reaches for various hydrographic surveys. As you can see in the image, the HydroBoat 1500 features a continuous hull design with compartment to obstruct the interior. This open design allows you to easily integrate larger survey equipment on board. High watertight installation bracket, then make mounting your equipment and managing cable breeze. In addition to its reinforced hull, the HydroBoat 1500 boasts a powerful propulsion system and enhanced resistance to water flow impacts. When operating in continuous canyon and during flood season, USV face strong currents, swirling eddies, and debris such as logs and truss. This known and unknown hazard significantly elevate the risk for personnel. Conventionally, USV may render inoperable due to insufficient power or damage problems, leaving them at the mercy of the strong currents. To address this challenge, the HydroBoat 1500 features a groundbreaking for thruster design, generating a total of 40,000 watts of thrust and enabling a maximum speed of 5.7 meters per second, which is more than adequate to handle even the most forceful currents. Even in high-velocity cars, the HydroBoat 1500 main control and maneuverability, preventing capsizing and being swept away by the debris or collision with rocks. This redundancy in thruster design ensures that the HydroBoat 1500 can navigate unforeseen hazards with confidence. To power the stronger thrusters, the HydroBoat 1500 comes standard with six high-capacity 35 ampere-hour lithium batteries. Additionally, the battery's balancing box integrated within the hull to ensure consistent voltage distribution across the multi-beam battery packs during the operation. The HydroBoat 1500 features three battery compartments, allowing for various battery configuration depending on the specific payload measurements. For multi-beam sonar system, we recommended using two batteries for further power and one battery to supply surveying equipment. But for lower power device like ADCP or single beam sonars, only two batteries are needed, as no additional power is required for the payload. Now let's turn our attention to USV control software. Similar to previous design HydroBoat 990, the HydroBoat 1200, the HydroBoat 1500 utilize an Android controller for remote control of the boat and built-in mini PC via 2.4 GHz and 4G networks. The 2.4 GHz frequency offers an effective control range of 1.3 kilometers, while 4G provides unrestricted range. This complementary controlling address control needs in different scenarios. The controller integrated as a Hydro USB Android software facilitates simplified unmanned boat control and mission planning. Meanwhile, the built-in industrial control computer directly receives and passes the data through a wired connection, eliminating concern about data transmission delays and losses. You can see the image shows that HydroBoat 1500 built-in IPC, industrial personal computer, with enhanced data integrity and real-time performance while eliminating data loss concerns. This Windows 10 machine allows for remote access not only through controller via local area network, but also remotely over the internet using software like TeamViewer or AnyDesk. The HydroBoat 1500 spares the data collection and processing, making it adaptable for various tasks and simplifying your workflow. After collecting the data in the field, you can turn to the office and process it on your personal computer. Here is an example of SatLab's multi-beam data processing software. The HydroBoat 1500 function as a carrier. The specific equipment you use determine the application and the required software. In a word, the HydroBoat 1500 is designed for flexibility and efficiency. Then let's delve into the external sensing system. In addition to enhanced full platform, stronger power system, and simpler control system, the HydroBoat 1500 boasts a reliable external sensing system that further bolsters its operational capabilities. Equipped with high-resolution omnidirectional camera, the HydroBoat 1500 provides real-time visual feedback to the operators, ensuring the boat remains within the site even during remote operation. Additionally, the HydroBoat 1500 integrates millimeter wave radar capable of scanning for a surface obstacle within 10 to 30-meter range. This capability effectively prevents collision between the unmanned vessel, multi-beam sonar, and underwater hazards such as reefs and shorelines, enhancing overall system safety, of course. That's further distance in the air. To further enhance navigation accuracy, the HydroBoat 1500 incorporates an inertial navigation module, ensuring the vessel stays on course even when passing under the bridge or through the shaded area where satellite signal may be lost or weakened. The 200 Hz IMU tightly coupled with GNSS ensure precise navigation along predefined routes. As you've seen from the previous presentation, I'm confident you've gained a basic understanding of this new USV. As a Swedish company driven by innovative technology, SatLab is able to integrate hardware and software, provide you with a turnkey solution for underwater topographic survey. The HydroBoat 1500 USV working together with HydroBeam and 4 multibeam sonar offers perfect combination. With just one USB and one remote control and no need for base station or complex network method, you can directly obtain high precision, resolution, and high efficiency underwater topographic data from the source. This solution offers numerous advantages, including fewer personnel, simpler installation design, lower personnel and equipment risk, more portable transportation, and solo water operation. The ability to measure every nook and cranny, of course, lower operating costs. In short, the HydroBoat 1500 is a USV perfectly suited for multi-beam surveying. Next, I'd like to share a few application cases with you. This is a case we conducted on an inland river this year, collecting high-density water depth data to check the impact of riverbed cover on bridge pier and flood control walls. As the number of cross-river bridges in cities has increased, the cover problem of bridge pier abutment and upstream and downstream flood control wall has also become increasingly serious. In recent years, the demand for such surveying projects has increased significantly. Traditional methods involve that either using manned boat to carry multi-beam for measurement or using single beam for encryption. The former method can still be used in large rivers, but it's impossible to carry out work in smaller rivers. Low bridge make navigation difficult, and there are many limitations such as draft and churning. Moreover, the safety of personnel is paramount importance. The accuracy and resolution of high beams are not ideal, but they are sometimes the only option. Now, USB-equipped with multi-beam can effectively solve the problem of insufficient data accuracy of single beams and the inflexibility of main boat in urban inland rivers. In this project, we use HydroBoat 1500 equipped with HydroBeam M4 to scan the underwater terrain and structure within 100-meter radius upstream and downstream of the bridge. The structures include bridge piers, abutments, and flood control walls. The total survey area was 85,421 square meters, and the system generated a high-density 3D point cloud with 8.8 million points at a resolution of 0.1 meters by 0.1 meters. The data was processed, visualized, and analyzed using our software. The result of the survey demonstrates advantage of using HydroBoat 1500 over main surface vessel. High precision, resolution data. The HydroBoat 1500 can collect high quality data suitable for multi-beam surveying tasks. Overcomes limit of manned vessel. The HydroBoat 1500 can navigate areas that are difficult or impossible for manned vessel to access and less disruption to waterway traffic. Unmanned vessels allow for continued use of the waterway by other vessels. The last one is reduce environmental impact. Unmanned vessels typically produce less pollution than manned vessels. So overall, HydroBoat 1500 offers an effective and efficient solution for underwater surveying. Underwater structure at hydroelectric station are constantly submerged and can develop problems like sedimentation and damage to the surface integrity over time. Traditional inspection methods have two main drawbacks. Diver-based inspection, limited by depth, time, and safety risks, divers also require specific environmental conditions such as calm water, equipment shutdown. Main survey vessel with multi-beam sonar, difficult to control in fast current and risk colliding with structure. Solution using a HydroBoat 1500 with multi-beam sonar. This approach offers several advantages. First, collect detailed data near structure due to the HydroBoat's small size and maneuverability, increasing efficiency and safety compared to the traditional methods. Overall, HydroBoat 1500 provides a safe and efficient solution for inspecting underwater structure at hydroelectric station. This image shows the upstream wear and the scour condition of the prefabricated blocks downstream. In this project, our compact HydroBoat 1500 small size allow us to navigate near the gate for measurement. Even in fast-moving current, the HydroBoat 1500's powerful motor ensures stability, demonstrating its ability to effectively capture structural data. In short, the HydroBoat 1500 can stably carry multi-beam sonar for efficient underwater surface in fast-moving currents while remaining close to structure for high-precision close-up scans. This is a brief introduction to the Ping 3D SatScan IDA 450. The Ping 3D SatScan IDX 450 is a 3D SatScan developed by Canadian company Ping DSP. It functions as both a 3D SatScan sonar and an ultra-wide SWOT shallow water bathymetry system, operating with a depth range of 0.5 to 80 meters. It can require three types of data in single pass. First, unprecedented high-resolution 3D scan point cloud data of the entire water column. And second one, high-precision SWOT bathymetry data with an ultra-wide coverage width. And the last one is 2D sonar imagery similar to traditional side-scan sonars. This capability makes the 3D side-scan IDX 450 particularly well suited for application in shallow water, coastal zones, various security and emergency response operations. Coupling the 3D side-scan IDX 450 with a high-performance unmanned surface vehicle like HydroBoat 1500 further enhance its capabilities, enabling the efficient execution of tasks that would be challenging or even impossible for traditional survey vessels. Overall, the Ping 3D SatScan IDA 450 and the HydroBoat 1500 form a powerful combination for acquiring high-resolution 3D data in challenging environmental. Here is the test where the Ping 3D SatScan IDA 450 sonar was mounted on a HydroBoat 1500 unmanned surface vehicle. The successful integration demonstrates the HydroBoat 1500 versatility beyond multi-beam sonar operation. It be equipped with various additional instruments to perform a wider range of tasks. Therefore, the HydroBoat 1500 we're releasing today is an USV designed for multi-beam surveying, but also compatible with variety of their equipment to meet diverse operational needs. These compatible instruments include multi-beam echo sounder, ADCP, single and dual frequency, single beam echo sounder, side scan sonar, also multi-parameter water quality sensors. This versatility allows the HydroBoat 1500 to be adapted for various tests. We were thrilled to introduce the HydroBoat 1500. Its compact size and powerful motor will revolutionize underwater data collection. Visit our website today to learn more and apply for a demo. Okay, thank you. Goodbye.